When we try to grasp the scale of the Milky Way Galaxy, we are confronted with numbers and distances so vast that the human mind struggles to comprehend them. The Milky Way, our galactic home, stretches across roughly 100,000 to 120,000 light years. That single measurement, stated so plainly, conceals a magnitude that no journey, no road, no earthly measurement can truly prepare us for. A light year is not a unit of time, as its name might suggest. It is a unit of distance, the distance that light, the fastest thing known in the universe, can travel in 1 year. Light moves at about 186,000 miles every second. In a single second, light can circle the Earth more than 7 times. Multiply that by 60 seconds, then 60 minutes, then 24 hours, and then 365 days, and you have nearly 6 trillion miles in just 1 light year. Now stretch that out across 100,000 light years, and you begin to see the staggering immensity of the Milky Way. We are talking about a span so wide that if you could build the most powerful spaceship imaginable, traveling at the speed of light itself, it would still take you 100,000 years to go from one edge of the Milky Way to the other. But let us slow down and try to picture it. Imagine standing on a quiet hill on a clear night, looking up at the sky, the hazy white streak that cuts across the heavens, the one our ancestors named the Milky Way, is not a cloud. It is the collective light of billions of stars, each one too distant to shine distinctly to our eyes. That streak is our glimpse into the vast disk of our galaxy, seen from within. You are looking at just one thin slice of the whole, yet even that slice stretches across the entire sky. Now imagine that same ribbon of light extended outward, not just across your field of vision, but in every direction, a disk so broad it dwarfs anything we know. The numbers we recite 100,000 light years across become not abstract figures but the reality of a colossal cosmic structure of which we are only a microscopic part. To understand scale, let's place ourselves inside the galaxy. Our solar system lies about 27,000 light years from the center, nestled in one of the spiral arms. That means even at the speed of light, a beam traveling from Earth toward the center of the galaxy would take 27 zeros. 0 years to arrive. That's longer than all of recorded human history multiplied many times over, and yet that is only the halfway point, only the distance to the galactic center, not to the far edges. If you were to continue beyond, you would need another 73 zeros, 0 years to cross to the opposite rim. And if you tried to journey along the spiral arms, twisting and curling outward from the middle, the distance might stretch even farther. The human brain is not designed to process such distances. Our instincts are shaped by walking, by seeing across valleys or oceans, by imagining journeys that take hours, days, or perhaps months. 100,000 light years is so far beyond those scales that even when we use metaphors, we fall short. Yet metaphors help. For example, imagine shrinking the entire Milky Way so that it fits inside the continental United States. On that scale, our entire solar system would be no larger than a dime. Earth itself, with all its history, civilizations, struggles, and triumphs, would be less than a speck of dust on that dime. That is the immensity of the galaxy. It humbles us, forcing us to see our place not as central, but as minute within a grand design. Astronomers attempt to map this enormity through observation and measurement. They calculate distances using the parallax of stars, the brightness of variable stars, and the redshift of faraway objects. From these tools, they stitch together a picture of a disk galaxy, flat and wide, like a cosmic pinwheel spinning slowly through space. Within that disk lies not just one neighborhood like ours, but billions of neighborhoods, each with suns and planets. The fact that it spans 100,000 light years across means that there are regions of the Milky Way so far away that their light, traveling at ultimate speed, left them before humans even walked the Earth. When we look into the galaxy, we are not only seeing distance but also time. We are looking backward across thousands and millions of years, seeing stars as they once were. The scale of the Milky Way becomes even more overwhelming when we compare it with the scale of human existence. Consider that the fastest spacecraft humanity has ever built, the Parker Solar Probe, travels at about 430,000 miles per hour. At that speed, it could circle Earth in less than an hour. reach the Moon in about half a day, and reach Mars in less than 2 months. That seems impressive until we place it against the galactic scale. At that incredible speed, the Parker Solar Probe would still take over 400 million years to cross the Milky Way from one side to the other. 400 million years, longer than the time since dinosaurs first appeared on Earth. Suddenly, even our greatest technological triumphs appear tiny, dwarfed by the sheer breadth of our home galaxy. And yet, despite its scale, the Milky Way is not infinite. It is vast, but it has structure and boundaries. Beyond its disk, stars thin out, and at its edges, our galaxy fades into the emptiness of intergalactic space. The very fact that it has limits means we can measure it, study it, and try to imagine it. But within those boundaries, the enormity of the Milky Way teaches us something about perspective. It shows us that our daily worries and concerns, while important in the context of our lives, are so small when measured against cosmic distances. It humbles us, but at the same time it elevates us. Because we, fragile beings clinging to a small world, have developed the intellect to measure these distances, to calculate the size of our galaxy, and to wonder about our place within it. The enormity of the Milky Way also speaks to time on a scale beyond human comprehension. Stars at one end of the galaxy may have lived and died long before their light ever reached us. Entire civilizations, if they exist elsewhere in the Milky Way, may have risen and fallen without our ever knowing, simply because the distances make communication impossible. Imagine a civilization 80,000 light years away. If they sent a signal to us today, it would not arrive until the year 82,025 A.D. We would not even exist to hear it, and if we replied, they would not receive our answer until another 80,000 years had passed. The scale of the galaxy creates barriers not just of distance, but of time itself. But perhaps the most extraordinary part of the Milky Way's immensity is that despite its overwhelming scale, it is still only one galaxy among billions. To us, its 100,000 light years feel infinite, and yet in the context of the universe, it is just one thread in a cosmic tapestry. This realization pushes us to expand our thinking, to acknowledge that our galaxy is both enormous and ordinary at the same time. Its scale is beyond our comprehension, yet it is only average when compared to giants like Andromeda, which stretches about 220,000 light years across, or other galaxies that span over 1,000,000 light years. So when we say the Milky Way is 100,000 light years across, we are stating a fact, but we are also expressing a wonder that goes beyond numbers. We are declaring that we live inside a structure so vast that it dwarfs our lifetimes, our histories, even our species. We are part of something that stretches across time and space in ways that our ancestors, who first looked up at the Milky Way as a river of light, could never have imagined, and yet they too felt the awe, the sense of standing under something greater than themselves. That feeling connects us across centuries, from ancient stargazers to modern astronomers, united by wonder at the scale of our galaxy. In the end, the enormity of the Milky Way is not just a scientific measurement. It is a reminder. It reminds us of our smallness, yes, but also of our ability to ask questions larger than ourselves. It reminds us that our lives, though brief, are connected to something that endures for billions of years. It reminds us that our home, this galaxy, is both a place of unimaginable distances and a cradle of life. Its vastness is intimidating, but it is also inspiring. For even if we cannot cross its 100,000 light years, we can imagine them, we can measure them, and we can let them expand our sense of what is possible. That is the power of truly understanding the scale of the Milky Way. It does not simply tell us how big our galaxy is. It transforms the way we see ourselves within it. The Milky Way is not just enormous in its size, it is equally staggering in what it contains. When scientists tell us that the galaxy holds between 100 billion and 400 billion stars, that number is almost too large to grasp. Our sun, the star we depend on for every breath and every heartbeat, is just one among hundreds of billions, a single grain of light in an ocean of brilliance. And around those stars, astronomers believe, orbit planets in such abundance that the number could reach into the trillions. To pause and think about this is to stand before a truth so vast it borders on the poetic. Our galaxy is not empty, but overflowing with worlds. Let's begin with the stars themselves. Each one is a sun, some smaller than ours, glowing dimly as red dwarfs, and some unimaginably larger, shining with blue-white intensity. Some are young, just beginning their fusion-driven lives, while others are ancient, nearing the end of their existence. In every part of the galaxy, from the dense central bulge to the winding spiral arms, stars burn in great numbers. Even the darkest patches of sky, where our eyes detect nothing, hold stars beyond the reach of naked vision. And though we often talk about the Milky Way as a flat disk, it is a three-dimensional structure, with stars above and below its plane, filling the galactic halo. When you add it all together, you arrive at those astonishing figures, hundreds of billions of stars bound by gravity into this one great spiral. But the true marvel is not just in the stars themselves. For centuries, people thought planets might be rare, special ornaments that only a few stars carried, yet modern astronomy has overturned that assumption. With the help of telescopes like Kepler and TESS, scientists have discovered thousands of exoplanets orbiting other stars, and the conclusion is inescapable. Planets are not rare at all, they are common. In fact, current research suggests that most stars in the Milky Way have planets, and many have entire systems, just like our own solar system. That means when we look at the night sky, nearly every star we see could be hosting its own family of worlds. Some of those worlds may be gas giants larger than Jupiter, some rocky and barren like Mercury, and some perhaps eerily Earth-like, with oceans, mountains, and atmospheres. If we estimate even one planet per star, the Milky Way could contain at least 100 billion planets. If many stars host multiple planets, that number rises into the trillions. This knowledge stretches our imagination. To think of Earth as unique is comforting. It is our home, our cradle, our sanctuary. But to think of Earth as one among trillions of possible worlds is both humbling and exhilarating. Somewhere in that galactic ocean there could be planets covered with ice, planets cloaked in fire, planets with two suns rising in their skies, and perhaps, just perhaps, planets where life has taken hold. The possibility of alien life has always fascinated humanity, but now it feels less like science fiction and more like a statistical certainty. With so many planets, the odds lean heavily toward life existing somewhere beyond Earth. Whether simple or complex, microbial or intelligent, we cannot yet say, but the sheer abundance of worlds makes it hard to imagine that we are alone. The distribution of stars and planets is also worth considering. In the galactic center, stars crowd close together, their gravity pulling and twisting in chaotic ways. Life there would be difficult, perhaps impossible, because radiation levels and gravitational forces would be extreme. Farther out, in the spiral arms where our sun resides, conditions are calmer. Here, stars are spread farther apart, giving planetary systems the stability they need to evolve. It is in these quiet neighborhoods that life-friendly worlds are most likely to form. This region is sometimes called the Galactic Habitable Zone, a cosmic sweet spot where conditions may allow for the emergence of life. When we imagine the scale of stars and planets in the Milky Way, perspective becomes everything. Think about it this way: if you were to try to count all the stars in the galaxy one by one, saying one number per second without stopping, it would take you thousands of years just to finish. And during that time, new stars would be born and old stars would die, changing the number even as you tried to tally it. The galaxy is not static, but dynamic. Stars are constantly forming in vast nurseries of gas and dust, like the Orion Nebula. At the same time, other stars are ending their lives in fiery supernova explosions, scattering heavy elements into space. Those elements then become the building blocks of new stars and new planets. This cycle of birth and death ensures that the galaxy is not just a collection of stars frozen in time, but a living, evolving system. Every planet, every atom, even the iron in your blood, was forged in the heart of some ancient star that once burned in the Milky Way. The abundance of stars and planets also expands our understanding of possibility. When we think about the diversity of environments on Earth alone, rainforests, deserts, oceans, tundras, it is easy to imagine how diverse planets in the galaxy might be. Some may be entirely covered in water, some may be giant frozen spheres, and some may orbit so close to their suns that their surfaces are seas of molten rock. There could be planets where it rains methane, planets with diamond mountains, planets with winds faster than the speed of sound. And with trillions of chances, there could also be planets with temperate climates, blue skies, and breathable air. To wonder about those places is to wonder about the great potential of the Milky Way, a galaxy so full of worlds that it defies imagination. It is not just about numbers, it is about what those numbers mean for us as human beings. Knowing that we live in a galaxy with hundreds of billions of stars, and perhaps trillions of planets can change our perspective on existence. It challenges us to see our place not as solitary, but as connected to a vast community of worlds. It urges us to be explorers, to reach out with our technology, our telescopes, and our imaginations, searching for signs of life and for places beyond Earth where life could flourish. It also deepens the sense of mystery. For all that we have discovered, we have only just begun. Thousands of exoplanets are confirmed, but they are a drop in the cosmic ocean. The rest remain hidden, waiting for us to detect them, to study them, to dream about what they might hold. The scale of stars and planets in the Milky Way also teaches us about humility and wonder. When we go about our daily lives, working, worrying, chasing goals, it is easy to forget that above us stretches a galaxy overflowing with stars and worlds. Every night, when we look at the sky, we are seeing only the smallest glimpse of this abundance. The Milky Way is so bright in dark skies, not because it is a cloud, but because so many stars blend together that their light merges into a river of white. That glow is a reminder, whispering to us about the countless suns and the countless worlds that lie beyond our reach. And yet, in this ocean of abundance, we know of only one planet with life, Earth. That rarity makes our world precious beyond measure. It is a jewel set in a galaxy of stone. While we marvel at the sheer number of possible planets, we are reminded to protect and cherish the one that has given us life. The richness of the galaxy does not make Earth less special. It makes it more so, because out of all the stars, all the planets, all the vastness, this is the one that carries us. This is the one that holds our histories, our families, our dreams. But the very possibility that life could exist elsewhere in the Milky Way excites something deep within us. It drives us to search, to listen for signals, to send probes, to imagine journeys to the stars. The knowledge that there are billions of other suns and trillions of possible worlds does not just humble us, it inspires us. It tells us that the story of life may be larger than our own chapter, and that somewhere in the great expanse of the galaxy, other beings may be looking at their skies, wondering the same things about us. So when we say the Milky Way holds hundreds of billions of stars and trillions of planets, we are not just stating a statistic, we are telling a story of abundance, of possibility, of mystery. We are describing a galaxy that is overflowing with potential, a galaxy that dwarfs our imagination and yet invites us to expand it. It is not emptiness we live in, it is richness, it is not silence, it is possibility. And in that abundance lies both our humility and our hope. For as small as we are, as brief as our lives may be, we are part of a galaxy that is vast, alive, and full of worlds waiting to be discovered. Our solar system has a very particular place in the Milky Way, and understanding where we are located within this vast spiral galaxy offers both scientific insight and a deep sense of perspective. When we ask where Earth is in relation to the rest of the galaxy, we discover that our solar system sits about 27,000 light years from the galactic center. That distance may sound like an arbitrary number, but it is an incredibly significant detail. It means we are not located near the bustling heart of the galaxy, nor are we banished to the farthest edges. Instead, we live in what can almost be described as a middle-class neighborhood of the Milky Way, a relatively calm and stable place that has allowed life to flourish on Earth. The Milky Way is shaped like a spiral, with long, curving arms extending outward from a dense, bright center. These arms are where most of the galaxy's stars, gas, and dust are concentrated. They resemble the flowing patterns of a whirlpool or the petals of a flower spiraling outward. Our solar system is located in one of these arms, specifically the Orion Arm, also sometimes called the Orion Spur. This arm is not one of the major spirals like Perseus or Sagittarius, but rather a smaller branch connecting them. And that location has proven to be just right. From here, we have enough distance from the galactic core to avoid some of the dangers that exist there, yet we are close enough to still be surrounded by a rich neighborhood of stars. If we were to live closer to the galactic center, our skies would be radically different. At the heart of the Milky Way lies Sagittarius A*, a supermassive black hole weighing millions of times more than our sun. Around it, stars crowd in so tightly that night skies would appear ablaze with starlight, far brighter than anything we know on Earth. But that beauty would come at a price. The gravitational forces, radiation levels, and violent activity near the galactic center make it an inhospitable region. Supernova are more frequent, gamma-ray bursts more common, and clouds of interstellar gas swirl chaotically. Such conditions would likely disrupt planetary systems, stripping atmospheres or bombarding worlds with deadly radiation. It is unlikely that a planet like Earth could have formed and survived in such a hostile environment. On the other hand, if our solar system were located near the farthest edges of the Milky Way, things would be different in another way. Out there, stars are fewer and farther between. The density of material is lower, which means fewer heavy elements, the very ingredients required to build rocky planets, water, and eventually life. Living at the edge might offer safety from galactic chaos, but it would also mean isolation and fewer resources. Earth might not have had the necessary building blocks for life had we been born out on the rim. Instead, we find ourselves positioned at just the right distance, far enough from the center to avoid destructive forces, close enough to the arms to have access to rich elements and a dynamic environment. This balance is often described as being part of the galactic habitable zone. Just as our planet has a habitable zone around the sun where liquid water can exist, our galaxy too has regions more favorable to life than others. Our solar system's place in this galactic zone may be one of the key reasons life could emerge and evolve here. The Orion Arm where we reside is not just our home, it is also our window into the broader galaxy. From this vantage point, when we look up into the night sky, we see not only the stars of our local neighborhood, but also distant views into other parts of the Milky Way. The familiar constellations we recognize, Orion, Cassiopeia, Cygnus, are made up of stars within our local region. Yet the soft, glowing band of the Milky Way stretching across the sky is the combined light of billions of more distant stars lying deeper in the spiral arms. Our position allows us to see enough of the galaxy to wonder about it, yet shields us from being overwhelmed by the brightness and chaos of denser regions. To understand just how remarkable our location is, imagine the scale of the Milky Way once more. With a diameter of about 100,000 light-years, our solar system is placed about halfway between the center and the outer rim. It is like living halfway between downtown and the suburbs of a great city. Too close to the city center and the noise and danger overwhelm you, too far out and you live in isolation. But in the middle regions you find stability, resources, and a balance between safety and activity. That balance is exactly what has allowed Earth's story to unfold. The Orion Arm itself is not empty. It is dotted with rich features of cosmic beauty. Nearby we find stellar nurseries like the Orion Nebula, where new stars are being born from clouds of gas and dust. We find clusters of stars like the Pleiades, sparkling like jewels in the night. We see remnants of past explosions, like the Crab Nebula, reminders of the cycles of life and death that fuel the galaxy. All of these wonders are within reach of our telescopes, and all of them shape our understanding of how the Milky Way evolves. The very fact that we can observe these phenomena so clearly is partly due to our location. Had we been deeper in dust clouds or closer to the blinding center, our view might have been obscured. Our solar system's orbit around the galaxy is another fascinating aspect of our location. Just as Earth orbits the Sun, our Sun orbits the center of the Milky Way. One complete orbit takes roughly 225 to 250 million years. That means that since the Sun and Earth formed about 5 billion years ago, our solar system has circled the galaxy about 20 times. During those long journeys, we pass through different spiral arms, encounter varying densities of stars, and experience different cosmic environments. Our location is never static, it is always changing, always moving through the great wheel of the galaxy. And yet, for now, we find ourselves in a relatively quiet part of an arm, free from the turbulence that other regions might bring. Thinking about this orbit puts human history into perspective. The entire span of recorded human civilization, 10,000 years, does not even register as a fraction of the Sun's galactic journey. All of human history has taken place in the tiniest sliver of one galactic orbit. The dinosaurs lived and went extinct without even completing a single orbit. Civilizations rise and fall, species evolve and disappear, yet the solar system keeps gliding around the galactic center on timescales that dwarf our own. This perspective does more than humble us, it inspires awe. To realize that we are not randomly placed but occupy a region that offers stability and resources is to see a kind of cosmic harmony. It is not that the galaxy was designed for us, but rather that life like ours could only have developed in certain places, and by fortune or by chance we are in one of them. That realization deepens our appreciation for how delicate and rare our circumstances are. From our position, we can also study the broader universe beyond the Milky Way. Being in a relatively thin region of the disk, not too clouded by dust, gives us windows out into intergalactic space. Through those windows, we see the Andromeda Galaxy, the Magellanic Clouds, and countless other galaxies beyond. These views are possible because of where we are positioned. If we had been in denser parts of the galaxy, our view would have been blocked, and we might not have even known other galaxies existed until much later in our history. Our location has not only allowed life to thrive, it has allowed curiosity and science to flourish. The Orion Arm is sometimes overlooked in descriptions of the Milky Way, as though it were a minor feature, but for us, it is the center of everything. Every star we have mapped, every exoplanet we have discovered, every nebula we have admired lies within reach of our local arm. And in the grand sweep of the galaxy, that arm is our neighborhood. It is where we were born, where we have grown, and where we will continue to drift for millions of years to come. Perhaps the most profound part of considering our solar system's location is what it means for our identity. We often think of ourselves as living on Earth in a particular country, in a specific city or village. We broaden that view and say we live on Earth orbiting the Sun. But if we go further, we see that we live not just in a solar system, but in a galaxy, in a specific arm, at a particular distance from its core. Our address in the cosmos is far more detailed than we usually acknowledge: Earth, solar system, Orion Arm, Milky Way Galaxy. To recognize that full address is to realize that our true home is not just this planet, but this galaxy, and that our destiny is tied to it. The story of our location in the Milky Way is not simply about coordinates, it is about context. It tells us why we are here, why life could develop, why we can look outward and see the stars. It places us in a narrative larger than ourselves, a narrative of cosmic positioning, balance, and motion. To expand on it is to appreciate how extraordinary it is that in a galaxy so vast, so filled with extremes, we occupy a place that is not only survivable but abundant with opportunity. So when we speak of our solar system's location, 27,000 light years from the galactic center in the Orion Arm of the Milky Way, we are not just giving numbers, we are describing the stage upon which the entire drama of Earth's history has played out. We are acknowledging the quiet, stable region that has sheltered us from destruction and given us the chance to evolve, to dream, and to wonder about the galaxy around us. And perhaps most importantly, we are recognizing that our place in the galaxy, though small, is precious. It has made us who we are, and it continues to shape who we might become. At the heart of our galaxy lies one of the most mysterious and powerful objects in the known universe, a supermassive black hole called Sagittarius A*. To understand the Milky Way fully, we cannot simply measure its size or count its stars. We must also peer into its very core, where gravity reigns supreme and space itself bends in ways we can barely imagine. Sagittarius A** is not just a curiosity, it is the anchor of the Milky Way, a gravitational engine that helps shape the motions of stars and gas across the entire galaxy. Expanding on this idea takes us into a realm where science and wonder intersect, where numbers cannot quite capture the enormity of what lies at our galaxy's center. The galactic core is about 27,000 light years from Earth, hidden behind thick curtains of dust and gas. To the naked eye, it is invisible, but through radio telescopes, infrared imaging, and X-ray observations, astronomers have pierced that darkness and revealed an environment unlike anything near our solar system. The stars in the galactic core are packed together far more densely than those in our neighborhood. While our sun is separated from its nearest star by more than 4 light years in the center, stars can be only a fraction of a light year apart, forming a cosmic metropolis of light and motion. These stars race around the black hole at incredible speeds, drawn by its immense gravity. By tracking their orbits, scientists were able to confirm the presence of Sagittarius A*, a black hole with a mass of about 4 million times that of our Sun. What does that mass mean in practical terms? Imagine compressing 4 million suns into a single point. That is the essence of a supermassive black hole, so much matter concentrated into such a small space that nothing, not even light, can escape its pull. Sagittarius A* itself is relatively quiet compared to more active black holes in other galaxies, but it is far from inert. Occasionally it flares with bursts of radiation, perhaps when gas or dust falls into its grasp and heats up before vanishing past the event horizon. These flares give astronomers glimpses of the violent processes that occur in the vicinity of such an object, processes that still challenge our theories of physics. The presence of Sagittarius A* also tells us something profound about the structure and history of the Milky Way. Black holes like this one are thought to form early in the life of a galaxy, growing by consuming matter and merging with other black holes as galaxies collide. Over billions of years, they settle into the centers of galaxies, exerting gravitational influence that helps hold the swirling stars in place. Without such an anchor, the motions of the Milky Way might be different, less stable, perhaps even chaotic. This supermassive black hole is not just a destructive force, but also a central pillar of galactic architecture. To appreciate the scale, consider the stars closest to Sagittarius A*. Some of them complete orbits in only a matter of years. One star called S2 swings around the black hole once every 16 years, reaching speeds of over 17 million miles per hour at its closest approach. Watching that star whip around an invisible point gave astronomers undeniable proof of the black hole's presence. For their work, Reinhard Genzel and Andrea Ghez were awarded the 2020 Nobel Prize in Physics. These observations were not just about confirming a theory, they were about directly seeing the effects of one of nature's most extreme objects right in the heart of our own galaxy. The black hole itself remains hidden. We cannot see beyond its event horizon, the boundary where escape is impossible. Yet in 2022, the Event Horizon Telescope collaboration released the first image of Sagittarius A*, a blurry ring of glowing material surrounding a dark shadow. That shadow is the black hole's silhouette, wet against the backdrop of falling matter. It is one of the most extraordinary scientific achievements of our time, a portrait of the invisible made visible. To look at that image is to confront the reality of something so powerful, so alien, that it defies normal comprehension, and yet it sits at the very center of the galaxy we call home. The galactic core is not just about the black hole itself, it is also about the environment it creates. Clouds of gas swirl around it, compressed by gravity and heated to extreme temperatures. Star formation is vigorous there, as dense regions of gas collapse to ignite new suns. But it is also a region of destruction, where stars may be shredded if they wander too close to the black hole, their material ripped apart and swallowed. The interplay of creation and annihilation makes the galactic center a dynamic, ever-changing environment. It is both cradle and grave, both nursery and tomb. For us on Earth, far away in the Orion Arm, the black hole is no direct threat. Its pull does not reach us across the vast distance of 27,000 light years. But indirectly, it shapes the galaxy we inhabit. Its gravity stabilizes the overall structure, and its past activity may have influenced the flow of gas and dust throughout the Milky Way. Some scientists believe that powerful jets of energy may once have blasted out of Sagittarius A*, clearing regions of the galaxy and affecting star formation. Evidence for this may lie in the Fermi bubbles, enormous structures of energetic particles extending above and below the plane of the galaxy, thought to be relics of ancient black hole activity. If true, it means the black hole's influence stretches far beyond its immediate surroundings, sculpting the galaxy on a colossal scale. The existence of Sagittarius A** also pushes us to wrestle with deeper questions about the nature of reality. Black holes are places where our current understanding of physics reaches its limits. Inside them, matter collapses to a point of infinite density, a singularity where space and time as we know them break down. Around them, time slows, light bends, and reality itself is distorted. That such an object exists in the heart of our galaxy is both unsettling and awe-inspiring. It reminds us that the universe operates on principles that challenge our imagination, and that much remains to be discovered. From a human perspective, there is something symbolic about the galactic core. It is the unseen center around which everything revolves, the hidden heart of the Milky Way. We cannot see it with our eyes, and yet we know it is there, shaping our destiny. There is a lesson in that. Not everything that influences us is visible, not everything important is obvious. Just as the black hole quietly governs the motions of stars, unseen forces, gravity, time, the laws of physics, govern our lives whether we notice them or not. The galactic core is both a scientific reality and a metaphor for the unseen depths of existence. When ancient humans looked up at the night sky, they saw the Milky Way as a river of light or a path to the heavens. They could not have known that at the center of that great arc of stars lay a force beyond imagination. Yet their sense of wonder was not misplaced. Today, we continue that tradition of wonder, but we add the tools of science which allow us to measure, to observe, to confirm. Our knowledge of Sagittarius A* does not diminish the mystery, it deepens it. Knowing that such a colossal object lies at the heart of our galaxy invites us to keep asking questions, to keep reaching for understanding. The galactic core, with its supermassive black hole, is a reminder of both danger and beauty. It is a region where matter and energy interact in violent, spectacular ways, but it is also a place of order holding the galaxy together. It is a paradox, a balance of creation and destruction, chaos and stability. And it is ours, the center of our cosmic home. Though we may never visit it, though its reality may remain forever distant and abstract, it is part of our story, part of what it means to say, we live in the Milky Way. In the end, to expand on the idea of the galactic core and its black hole is to acknowledge the dual nature of the universe. It is vast and violent, but also ordered and sustaining. It contains forces that can terrify, yet those same forces are necessary for the structure that makes life possible. The black hole at the heart of the Milky Way is not an enemy, not a monster waiting to devour us. It is a fundamental part of the cosmic balance. It is the hidden center, the gravitational heart, the silent engine around which our galaxy turns. And knowing it is there changes the way we see our place in the cosmos. It reminds us that even in the face of unimaginable power, we are capable of discovery, of comprehension, of awe. That is the gift of understanding the galactic core. It does not merely tell us what lies at the center of the Milky Way. It shows us the grandeur of a universe where even the most terrifying objects can be sources of beauty, mystery, and meaning. When we talk about our galaxy, the Milky Way, it's easy to imagine it as the ultimate unit of the universe, a complete island of stars floating in space, self-contained and solitary. But the truth is, the Milky Way is not alone. It is part of something much larger, something even more awe-inspiring, a vast cosmic network of galaxies bound together by gravity. To understand just how big our galaxy really is, we must see it not just as a collection of billions of stars, but as one member of an enormous family stretching across the universe. This perspective reveals that the Milky Way is a grand structure on its own, yet also a small piece of a far greater whole. The Milky Way belongs to a cluster of galaxies known as the local group. The name might sound humble, almost casual, but the local group is anything but small. It spans more than 10 million light-years across and contains more than 50 galaxies, large and small. Within this family, the Milky Way is a heavyweight, but not the only giant. The Andromeda Galaxy, our nearest large neighbor, is even bigger, holding perhaps 1 trillion stars compared to the Milky Way's estimated 1 to 400 billion. The two galaxies, Milky Way and Andromeda, dominate the local group like twin monarchs, each surrounded by smaller satellite galaxies that orbit them. Among these smaller companions are the large and small Magellanic Clouds, visible from the southern hemisphere as fuzzy patches in the night sky. These are irregular dwarf galaxies bound by the Milky Way's gravity, trailing streams of stars and gas as they dance around us. There are also dwarf spheroidal galaxies, faint collections of stars barely visible against the cosmic background, yet gravitationally tied to our galaxy. In this way, the Milky Way is not simply an island, but the hub of a small archipelago with smaller companions orbiting its vast spiral disk. The relationship between the Milky Way and Andromeda is particularly fascinating. They are currently separated by about 2.5 million light-years, but they are on a collision course. In about 4 billion years, the two galaxies will begin to merge in a titanic cosmic event. Stars will not typically collide, because even in dense galaxies the distances between stars are enormous, but the gravitational forces will distort both galaxies, pulling out tidal streams of stars, gas, and dust. Eventually, after billions of years of this slow-motion collision, the two spirals will settle into a single giant elliptical galaxy, sometimes referred to as Milkomeda. This future merger reminds us that galaxies are not static. They are dynamic, ever-changing structures in a universe governed by gravity's relentless pull. But the local group itself is just a neighborhood in a much larger city of galaxies. Surrounding the local group are other galaxy groups and clusters, and altogether they form part of a vast supercluster called Laniakea, a Hawaiian word meaning immense heaven. Laniakea spans about 520 million light-years and contains more than 100,000 galaxies. To put this into perspective, if the Milky Way were a single grain of sand, the entire supercluster would be a beach stretching farther than the eye could see. And even Laniakea is only one among countless superclusters woven into the cosmic web, the vast structure of the universe. The cosmic web itself is one of the most profound discoveries in modern astronomy. Galaxies are not scattered randomly through the universe. They are arranged in filaments, long strands of galaxies and dark matter stretching for hundreds of millions of light-years, intersecting at nodes where clusters of galaxies form. Between these filaments lie vast voids, regions of space nearly empty of galaxies. The Milky Way, the local group, and the Laniakea supercluster all occupy one strand of this great cosmic web, like pearls strung on an invisible thread of dark matter. This architecture is the skeleton of the universe, and our galaxy is just one small piece of it. To fully appreciate what it means for the Milky Way to be part of such a structure, we need to think about scales. A light-year is nearly 6 trillion miles, and our galaxy is about 100,000 light-years across. That is already a number beyond ordinary comprehension, but the local group is 10 million light-years across, and the Laniakea supercluster 500 million. The observable universe, the portion we can see with our telescopes, stretches for 93 billion light-years across. Within it, scientists estimate there are around 2 trillion galaxies. That means the Milky Way, magnificent as it is 1 out of 2 trillion. It is special to us because it is our home, but in the grand scheme it is one tiny thread in an almost infinite tapestry. Yet, this perspective does not diminish the Milky Way's importance. It enhances it. The fact that we live in a galaxy that is itself part of a group, a cluster, a supercluster, and a cosmic web shows us that the universe has layers of structure, each larger and more complex than the last. Just as a single star is part of a single galaxy is part of a larger family. The patterns repeat on different scales, reflecting the unity of cosmic design. This hierarchical organization, from planets around stars to stars in galaxies to galaxies in clusters to clusters in superclusters, reminds us that the universe is interconnected, that everything belongs to something greater. The Milky Way's place in this hierarchy also sparks questions about life and perspective. If there are 2 trillion galaxies in the observable universe, each with billions of stars, then the number of possible planets is staggering. Many of those planets may lie in habitable zones, with the potential for water, atmospheres, and perhaps life. From this angle, the Milky Way is not just a home but also a laboratory, one example among many in which the grand experiment of life may unfold. We wonder, are we alone, or are there other civilizations looking up at their night skies, asking the same questions we ask? The fact that our galaxy is one of trillions means the possibilities are endless, and the mystery profound. Another way to grasp the Milky Way's larger context is to look at its motion. Our galaxy is not stationary, it is moving through space at hundreds of kilometers per second. It is being pulled by the gravity of other galaxies, clusters, and structures. In fact, the entire local group is falling towards something called the Great Attractor, a region of space within Laniakea where the combined gravity of countless galaxies draws everything toward it. This motion reveals that galaxies are not isolated islands drifting randomly. They are rivers flowing within the currents of the cosmic web, influenced by invisible tides of gravity and dark matter. The Milky Way's journey is part of a larger dance of structure formation, one that began with the Big Bang and continues to this day. From a human perspective, recognizing that the Milky Way is part of such a larger structure can be both humbling and inspiring. It humbles us because it shows us that our galaxy, which already seemed unimaginably large, is but a small component of a universe that dwarfs even our greatest ideas of scale. It inspires us because it means there is no end to discovery. Beyond our galaxy are countless others, each with its own mysteries, its own stars, its own histories of birth, death, and transformation. Every telescope we build, every mission we send into space, opens a new window into that vastness, giving us glimpses of galaxies colliding, stars being born in distant nebulae, or light from objects billions of years old reaching us across time. And yet, even as we expand our perspective, the Milky Way remains central to us. It is our vantage point, the platform from which we gaze outward. We are not separate from the cosmic web, we are woven into it. Our galaxy's place in the local group in Laniakea, in the universe at large, is not just a scientific fact but a reminder of belonging. We are citizens of Earth, yes, but also of the Milky Way and by extension of the universe itself. Ultimately, to say that the Milky Way is part of a larger structure is to recognize a profound truth. Nothing exists in isolation. Just as stars belong to galaxies, and galaxies belong to clusters, so too do we belong to something greater than ourselves. The same principle that governs the cosmos applies to human life. We are connected, interdependent, parts of a whole that is more than the sum of its parts. The universe reflects this interconnectedness on every scale, from atoms to galaxies to superclusters. The grandeur of this perspective is staggering, but it also leaves us with a sense of wonder. The Milky Way is vast beyond comprehension, yet it is only one among trillions. Its place in the local group, in Laniakea, in the cosmic web, shows us that we are living in a universe without edges, without boundaries of imagination. And within this immensity, we tiny beings on a small planet orbiting an average star have the ability to comprehend, to explore, to map the structures of existence itself. That is perhaps the most astonishing fact of all, that the universe, in all its incomprehensible size, has produced within one of its galaxies a species capable of asking, "How big is our galaxy?" and then finding the answer. When we step outside on a clear night and look up at the Milky Way stretching across the sky, it is easy to feel overwhelmed by its sheer beauty and mystery. That glowing band of light is not some trick of the atmosphere or a random scattering of stars. It is our galaxy seen from the inside, a collection of billions of suns so numerous and distant that their light blends into a single shimmering ribbon. For thousands of years, humans have gazed upon it with awe, telling stories, weaving myths, and trying to make sense of what it means. Today, with the tools of modern science, we can measure its size, map its structure, and even locate our position within it. But beyond the facts and figures lies something even more powerful, the way the galaxy makes us feel and what it tells us about ourselves. The human perspective on the Milky Way is one of humility, wonder, and the profound realization that we are part of something unimaginably vast. To begin, consider how small we are in relation to our galaxy. The Milky Way is about 100,000 to 120,000 light years across. A light year, the distance light travels in a single year, is nearly 6 trillion miles. Our fastest spacecraft, moving at tens of thousands of miles per hour, would take tens of thousands of years just to travel a tiny fraction of that distance. Our entire solar system is less than a speck on this scale. If the galaxy were shrunk down to the size of North America, our solar system would be smaller than a quarter, lying somewhere in the middle. To realize this is to feel the humbling truth that we are not the center of the cosmos, but rather a small part of a much larger whole. Yet within that smallness lies something extraordinary, the ability to understand. The stars themselves do not know they are part of a galaxy. The gas clouds do not comprehend that they are recycled into new suns and planets. But we, fragile creatures on a small blue planet, have developed minds capable of asking questions about the universe and building instruments to find the answers. That alone is a source of wonder. The Milky Way reminds us that even though we are small, our curiosity and imagination are immense. For ancient people, the galaxy was both a guide and a mystery. Some cultures saw it as a celestial river, others as a pathway for souls, others still as a scar across the heavens. It was woven into stories of creation, journeys, and destinies. These myths were not mistakes, but reflections of wonder, the same wonder we feel today, even if our explanations have changed. Where they saw gods and spirits, we see stars and galaxies. But the emotional impact is much the same, a sense that the night sky is not just empty darkness, but a canvas filled with meaning. Today, science has expanded that sense of wonder rather than diminished it. When we say that the Milky Way contains between 100 and 400 billion stars, each potentially with its own planets, we are not reducing its magic, we are multiplying it. Every star is a possibility. Every planet is a question. Are we alone, or is life scattered across the galaxy, waiting to be discovered? The thought that there could be other civilizations looking up at their skies, pondering their place just as we do, fills the galaxy with even deeper significance. It becomes not just a structure of gas and stars, but a theater of possibilities, a backdrop for countless stories yet untold. Our position in the galaxy adds another layer to this perspective. We are about 27,000 light years from the center in a relatively quiet suburb known as the Orion Arm. From here, we can look inward toward the crowded, energetic core with its supermassive black hole, or outward toward the sparse, cooler edges. In a way, our location is ideal. Too close to the center, and the radiation and density of stars might make life impossible. Too far out, and we might lack the heavy elements necessary for planets and biology. It is as if we occupy a cosmic sweet spot, not just in our solar system around the sun, but also in the larger structure of the galaxy. This realization deepens the sense of wonder because it suggests that our existence is not random chaos but the product of an extraordinary alignment of conditions. From a human standpoint, the galaxy is both intimidating and comforting. It intimidates because it dwarfs us. The distances are beyond comprehension, the numbers beyond calculation, the timescales beyond imagination. Stars live and die on scales of billions of years. The galaxy itself has existed for over 13 billion years, long before humanity, long before Earth itself. Compared to that, our entire history, the rise and fall of civilizations, the writing of books, the building of cities, is the blink of an eye. To know this is to confront our own fragility, the brevity of our lives, the fleeting nature of our struggles. And yet, strangely, it is also comforting because the galaxy endures. Long after we are gone, the stars will continue to shine, the spiral arms will continue to turn, the Milky Way will continue its slow dance through space. Our worries and fears, enormous as they seem to us, are small compared to the grandeur of the cosmos. The galaxy reminds us that life is short but precious, that we are part of a story that began long before us and will continue long after. It gives perspective, a kind of cosmic humility that makes room for gratitude. There is also wonder in simply existing within such a place. Think about what it means to be alive on a planet orbiting a star, inside a galaxy of billions of stars, within a universe of trillions of galaxies. Out of all the possible places and times we are here now able to see, to think, to feel, that improbability is staggering. It suggests that life itself is a kind of cosmic miracle. The Milky Way, vast as it is not just a collection of matter. It is a stage upon which consciousness has arisen. That consciousness, in turn, allows the universe to reflect upon itself, to look inward and outward simultaneously. From this perspective, the question, how big is our galaxy, becomes more than scientific. It becomes philosophical, even spiritual. The answer is not just a number measured in light, years, but an invitation to reflect on our place in the universe. It tells us that we are small, but also that we are significant in a different way, not because we dominate the cosmos, but because we can appreciate it. The galaxy does not need our recognition, but we need the galaxy's reminder that we are part of something infinite. The more we study the Milky Way, the more layers of wonder we uncover. We see stars being born in glowing nebulae like the Eagle Nebula's pillars of creation. We see stars dying in violent supernova, scattering heavy elements that one day form new planets. We see the spiral arms winding like grand rivers of starlight, each one containing more suns than we could ever count. We even see evidence that the galaxy itself is alive in a sense, changing over time, merging with others, growing and evolving. These discoveries do not make the galaxy less mysterious. They make it more alive in our imagination. For humanity, the galaxy is also a horizon of possibility. Already we have sent probes beyond our solar system, carrying golden records with messages to the stars. Already we are dreaming of interstellar travel, of one day sending ships to nearby star systems like Proxima Centauri. These are small steps compared to the scale of the Milky Way, but they are steps nonetheless. The galaxy inspires us to go further, to reach higher, to believe that exploration is part of our nature. It is not just a backdrop, it is a challenge, a call to adventure. And finally, the wonder of the Milky Way is not just out there in the sky, it is within us. Every atom in our bodies was forged in stars, the carbon in our cells, the calcium in our bones, the iron in our blood. All of it was created in stellar furnaces billions of years ago. We are literally made of stardust. When we look up at the galaxy, we are not looking at something separate from us. We are looking at our origins, at the cosmic process that made us possible. The galaxy is not just our home, it is our parent, our ancestor, our source. So when we ask how big is our galaxy, we are really asking how big is the story we are part of. The answer is beyond imagination, measured not just in light, years, but in wonder. The Milky Way humbles us, inspires us, and connects us to something far greater than ourselves. It shows us that even in a universe so vast, our capacity to feel awe, to seek knowledge, and to dream gives us a kind of greatness too. We may be small, but we are not insignificant. We are the universe becoming aware of itself, and the galaxy is the mirror in which we see that truth. That is the human perspective. That is the wonder of the Milky Way.